Hello everyone, my name is Serrano. I'm an associate professor at the University of Toulouse in France, and today I'm going to present a work that was carried out by Kaixing Zhao, Mulet, Clara Sorita, Bernard Oriola, and Christophe Jouffrais. And this work we try to understand what are the current practices and to co-design an accessible tool with special education teachers specifically for remote graphic-based teaching. So our work, the context of our work is that, so we witnessed the difficulties that special education teachers and pupils with visual impairment experienced during the lockdown and the COVID-19 context. And they had many difficulties to attend face-to-face lessons because those pupils have mobility issues. They also have or may have some economical reasons. And there is a scarcity of special education centers. And so there was this need that emerged about the need for novel tools to ensure accessible online teaching for those teachers and pupils. So to explore or regarding this context, we decided to explore a research question, which is what are the current practices of special education teachers and what will be the design requirements for a remote accessible teaching tool based on graphics specifically, because this is something that will be more specifically difficult when teaching online. So we contribute with a survey and a series of focus groups. The idea of the survey or the survey contributes with a description of the current practices of special education teachers and how they adapted to a forced remote teaching situation. The focus group led to a set of design recommendations of a remote graphic-based teaching tool for pupils with visual impairment. And we also contribute with a general discussion to summarize our findings and envision the development of the tool. So I will not dive into the details of this general discussion, but you can find all the details in our paper. So here you have the timeline of our work. So you can see that, so we conducted first a survey, then 2 general focus groups, and then 2 specific focus groups, the 3 and 4. In between the survey and the focus group, we designed a low-fidelity prototype that was used to drive the discussion on the focus group 1. And then in between the focus group 1 and 2, we started to develop to design a second low-fidelity prototype that was used to drive the discussions of the upcoming focus groups. I'm going to detail each one of them in the following slides. So the goal of the preliminary survey was to collect the issues that special education teachers experienced during the lockdown and how they adapted or changed their practices to adapt to the situation. We had 59 special education workers, which were either special education teachers or orientation and mobility instructors that answered our survey. And well, we first asked them what were their use of digital tools, and we can see on the left that both special education workers and pupils with visual impairment use digital tools, so mostly computer and smartphones, but also some special tools for the pupils. And that regarding the usage frequency, they use them mostly daily, so something that they're actually using. So the results of the survey is that regarding the adaptation of the teaching during the lockdown, many teachers told us that they had to stop or limit their teaching activities, and that their main goal during that period was to maintain a close contact with the people in care and their families. So actually drop a little bit the teaching goal. And they didn't come up with any specific tool for compensating this limited teaching activity. So regarding their needs and ideas for improving remote teaching, although most of these teachers experienced difficulties, they made few notable changes to their practices. And one of the things that raised concerns was remote monitoring, so knowing what the pupil is doing on the other side. And they will need applications that allows to share documents and screen, but also that adapt to the teaching strategies. And overall, what they need is tools that are simple to use. So taking these considerations, we designed the first low-fidelity prototype. The goal of this prototype was to drive the following focus groups and to gather ideas. And so This prototype was based on using a tablet, a commercially available tablet, both for the teacher and the pupil, as a way to display or explore graphics. So this prototype had a number of functionalities. The first functionality was annotation. So the teacher could add annotations on the graphic that could be explored by the pupil using touch on the tablet. The second one was navigation. So multi-level navigation. So the teacher could define different levels or predefine different levels of navigation with different zoom levels or pan levels, which can then be explored by the pupil. Another functionality was the remote tracking function. So the idea was that when the pupil with visual impairment is touching the graphic, the teacher has a feedback on a real-time feedback on where this touch is happening as a way to have or to gain awareness on what is happening. So we use this prototype to drive our first focus group. So the idea of the focus group was to validate the interest for the prototype and also try to ask about what utility and usability issues they will anticipate on this prototype. So in this focus group, we had 6 special education teachers. The idea, we work on a global COVID-19 propagation scenario. So here the graphics will show the world, and the pupil and could explore the numbers of the COVID-19 propagation on this graphic. And the procedure was that after introducing the general focus group and presenting the prototype, we had a general set of discussion and questions with those special education teachers. So the outcomes is that they thought the prototype is interesting, and that it should be combined with Resin overlays, because they thought that having a 100% Dutch interface will be too difficult for the pupils. They believe that the annotation function is necessary for both teachers and pupils, but they believe that the navigation function is probably too complicated and that it should not be integrated because it could raise some accessibility issues. Having a hand movement tracking was believed to be mandatory. And something to consider, or they were worried about, is how to allow the teachers to prepare those interactive graphics. So taking these outcomes, we designed a second low-fidelity prototype, which was based again on the tablet, but here with a tactile overlay. And we also, so we developed an authoring software, which was used to prepare the interactive graphics, and a reader, which can be installed on any touch-sensitive screen. So using this tactile overlay prototype, we designed a second, or we drive the second focus group. The goal was to discuss the potential usages of the device. So what are the potential application scenarios, who, where, and how, as well as the potential usability issues. We had 4 special education teachers and 2 orientation and mobility instructors working again on this global COVID-19 propagation, and we followed the same procedure than in the previous focus group. So regarding the outcomes of this focus group, participants believe that this tool could be interesting with pupils with VI, but they thought that this will be useful mostly for pupils that have some previous knowledge, so kind of expert pupils. They believe that it could be interesting for both general instructional activities in STEM-related areas, but also to gain additional skills for orientation and mobility instruction. They thought that this could be used both, this prototype could be used both as a homework, but also to conduct remote orientation and mobility lessons. And they believe that this device or this prototype could be useful because it could foster participation and inclusion of the pupils, and it could they saw that it could be extended to non-lockdown tasks. Regarding the potential issues of the prototype, one question was how to provide the device to the pupil, and also they had instructional considerations as, again, how to prepare the content. So we decided to conduct 2 other focus groups, focusing on the 2 application areas that were identified, so either general teaching or orientation and mobility instruction. So we had in one focus group, we had only orientation and mobility instructors, and the other one, we had only special education teachers. The scenario for the orientation and mobility was a school building map to be explored, whereas for the special education teachers, it was a Grand Voyage map. And we followed the same procedure than in the previous focus groups. So the outcomes of the third focus group on orientation and mobility is that they believe that the device should allow progressive exploration, so not showing all the content at once, but adding progressively the content. It should support task-based learning and, again, keep tracking of hand movements. Regarding the interactions, they believe that having audio feedback could reinforce spatial learning, while vibratory feedback could be used to indicate, for instance, dangerous places in orientation and mobility. Regarding how to lead the session, they believe that it's important that the teacher has direct access to functions, so they could activate or deactivate the functions. The annotations, the use of annotations should be restrained because it could overload the pupil. There was also this idea that the device could change the awareness of the pupils and the teachers on this online teaching. So regarding the outcomes of the last focus group 4 on general teaching, they also believe that having a progressive exploration is important. So again, being able to add the content progressively, not put all the content at once. And that it should support both synchronous and asynchronous teaching. So the pupil working by himself at home. They also believe that audio feedback is necessary. And regarding how to lead the session, they thought it would be interesting for the teacher to have a menu that will give him access to different functions as a way to dynamically change or conduct the session. So to summarize, teachers told us that they experienced difficulties during the lockdown, and while their goal was to focus on keeping contact, they made no significant changes in their use of digital tools, and they lacked specific tools for remote teaching. So there was this need for remote graphics teaching tool that emerged, and it's important that these kind of tools have some type of tactile overlay, and that they support remote hand movement monitoring as a way to let the teacher gain awareness on what the pupil is doing. And it's important that those tools are versatile so that they can adapt to different professions and teaching situations. And so these tools can be used, this prototype is something that will be useful to be used in instructional activities that involve some type of graphics. So regarding our perspectives, well, now we want to implement the tool and deploy it in a special education center, and then conduct a longitudinal evaluation in the field. Thank you for your attention.